Hi guys, welcome back to BDAS on Academy Tutorial. Thanks for joining us today. Today I'm going to be considering a topic under mathematics known as mensuration. And here is the question. Let's go into it. The frustum of a cone, the bottom diameter is thrice the top diameter. Now, in a frustum of a cone, the bottom diameter is 3 times the top of what? Of the top diameter. Now, when I'm talking about cone or a frustum of a cone, it's a part of what? A cone that is being brought out. And then let's look at how it looks like. Now we are told that that frustum of that cone has its bottom diameter thrice of that of the what? The top one. Now if I want to draw a cone, this is how a frustum look like. A frustum look like something like this. It look like that of lamp. When you look at the bed lamp or table lamp. So we have, and then the bigger what? Diameter here. Okay, this is how it look like. If you look, imagine the table lamp in your bedroom. You will see something like table lamp that has something like this, and then it has a stand underneath. So this is how frustum look like. So now we have this is a frustum, and we are told that the bottom diameter is thrice the top diameter. Now this is a circle, and every circle has a diameter. This is a circle, and every circle has a diameter. They now told us that this bottom diameter is 3 times the what? The top diameter. So meaning that if this diameter is x, if this diameter is x, the diameter of this, let me draw it very well, is x, then the bottom diameter will be 3 times x. So that's what they are trying to say here. That if the top diameter is x, then the bottom diameter will be 3 times x, because it is 3 times the top diameter. So this is the bottom diameter, this is the top diameter. So now this is the interpretation of the first information given to us. Now they now say if the height, if the height of the frustum is 12 centimeters. Now what do you mean by that? If the height of this frustum, when you trace this out like this, let me trace it out. Let's trace it out like this, and then trace it out like this. So the height of the frustum here is, that is from here to here, is 12 centimeters. Now the height of the frustum is 12 centimeters. Calculate the height of the whole cone. So how do we get the height of the whole cone? Meaning that you have to complete this cone. We have to complete it. So how do you complete it? You have to draw something like this. I'm going to try and sketch it and come up with something. So if I use a dashed line to complete the cone, let me just say, okay, this is my apex, and then try and join it here. Not perfect, but at least let's form a cone. So now this is a cone here, this is a complete cone. They now ask us, what is the height of the whole cone? So meaning that to get the height of the whole cone, we must get the height of this from here to here as well. Let me call this one. Use an arrow to draw this one down. Yeah, so here this one. I'm using dash line so that you can get what I'm trying to do, because it's not actually what. This one I'm using dash line is because it was not actually the shape given to us. We are just trying to form the whole cone, so now to get the height of the whole cone itself. So from here to here is the height of the whole cone. Don't forget the height of the frustum is 12 centimeters, but we are asked to calculate the height of the whole cone. So meaning that we need this place y, I label it y centimeter, to actually get the whole cone. The height of the cone will be equal to y centimeter plus what? 12 centimeter to get it. Just note that. So, but the first thing is to get the y centimeter first. And how do you go about that? That's the crucial question to ask ourselves. Now, there's something we call similar triangle. You use similar triangle, where there's a principle we use in similar shapes. Let me limit it to the triangle. There are some principles that we use in similar shapes. When something has similar shapes, or they are in ratios to each other. So we use this method and this principle in this question as well. You are going to relate some parts together, and then you are going to compare them together in order to get your height, and then subsequently get, or in order to get your y, and then subsequently get the height of the what, of the cone itself. So now how do we use this principle of comparison? This principle of comparison, what we are going to do is that, okay, if we have the whole cone, this is a whole cone here, and then there's a smaller cone on the top. Consider the whole cone from here to here, and then the smaller cone from here to here. So what I'm going to do is that I'm going to say, okay, let the diameter of this, I'm going to put the diameter of this in ratio to what? To the height of the cone. The diameter of the what? Of the smaller cone all over the diameter of the smaller cone all over the height of the smaller cone, which is y. I hope you are following. The height of the smaller cone, the diameter of smaller cone all over the height of the what? Smaller what? Cone. So then is equal to the height of the bigger cone. Okay, the diameter. We are considering diameter this time around. The diameter is considered first here. So you are going to consider the diameter in the whole cone as well. So if we use the diameter of the smaller cone all over the height of the smaller cone, you must also use the diameter of the whole cone all over the height of the whole cone. So the diameter of the whole cone is what? 3x over the height of the whole cone, which is y plus 12 centimeter. I hope you are following. So if you are following the simple analogy, this x will definitely cancel this x because they are on either sides. So if this one cancel this out, you can easily get your what? Your y now. X has cancelled out. So we have what? By cross multiplication, we have 3y equal to y, because this one has turned to 1, plus 12. So by so doing, we can say, oh, okay, transfer this y to the other side. So it's going to be 3y minus y, which is 2y equal to 12. So divide both sides by 2, definitely you know your y now. Y is equal to 6 centimeter. So meaning that the y here is 6 centimeter. So if this y here is 6 centimeter, then what was the height of the bigger cone? So you are just, okay, therefore the height of the whole cone itself is going to be what? 6 plus 12. Don't forget to put your unit. 6 plus 12 is going to give us what? 18 centimeter. Very, very important. So that's the first question. Meaning that what? The height of the whole cone is 18 centimeter. So it's not that far-fetched. It's a simple question. Just have to use some analogy to actually get it. So having gotten the A aspect of the question, we are asked to calculate the volume. They said, given that the volume of the whole cone is 39,600 centimeter cube, find correct to first significant figure, the radius. Find the correct to significant figure, the radius. Why are they actually giving us this? Actually, we are asked to calculate the radius, and we are given specific volume now in order for us to get the radius of the whole cone. Assuming we are told to use this, we will have actually go by this and get but nevertheless, they didn't ask us to go by this. We are told that the new volume now that we are given is 39,600 centimeter cube, and we are asked to calculate the radius of that whole cone to 4 significant figure. So now let's jump into it. So what I do now is to quickly clean this and leave the diagram alone. We know that the height of the whole cone now is now 18 centimeters, so I can easily clean this and say, okay, from here to here is, from here to here is 18 centimeter now, and then we are looking for, we are less concerned about this one, but we are concerned about the whole cone here. So we are looking for the radius of this whole cone here. So the radius here is what we are looking for, which are represented as capital letter R, because this radius here is going to be small letter r. But we are less concerned about this. We are much concerned about the capital letter R here. So I'm just showing you how you can do things when it comes to bigger and smaller cone. So you can label this one R and label this capital letter R. But the major concentration is this whole cone with the capital letter R. So if that be the case, I can simply clean this whole circle here because it's not our concern now. This is the whole cone. If you have to consider it is the whole cone. Now, and then when we're looking at the whole cone like this, you see the radius capital letter R and the height comparing to this, which is 18 centimeter. So this is how the whole cone look like. Now, so with this now, to calculate the volume of a cone, you must know the formula offhand. If you don't know the formula offhand, there is what we call four-figure table, a book of formula that comes with what? With you when you are writing an exams. You have to bring that book inside in order to recall some formula. But you need to know those formulas, where those formulas are, in order for you to apply them in exams. But my advice to our students is that try to master the formula instead of you trying to look at the formula in the exams. If you master the formula very well, you don't need to use your four-figure table and try checking, because it will have become part of you. So now the volume of a cone, the formula for volume of a cone is actually V is equal to 1/3 pi r square h. This is the formula of a volume of a cone. But because I'm using the capital letter R, I'm going to change this one to capital letter R. So 1/3 pi r square h, that's volume of a cone. So from there, we can easily get our R, which is the bigger radius of the whole cone. So here we have R to be unknown and H to be 18 centimeter. Here we are given that R is unknown, but H is 18 centimeter, and then the volume itself is 39,000 from the question. 39,600 centimeter cube. So we can easily now substitute all these parameters. So we have 39,600 equal to 1/3 multiplied by, don't forget the pi given to us is 22/7. 22/7, so 22/7 multiplied by r square multiplied by 18. Wow. So we are going to say, okay, 3 here 1, 3 here 6. So that one has eliminated that now. So with this now, you can easily multiply this and this together. So this is going to be 39,600. When you cross multiply with this, I'm going to cross multiply immediately like this. It's going to be times 7 equal to, this one is going to be over 1. So 7 times this and this 1 times this. So 1 times 22 times 6. Let me write that 6 first. Times r square. So by so doing, you can divide both sides by 22 times 6. 22 times 6. So to save your time, so this one cancel out. So by so doing, you can easily press this on calculator. Let me bring my calculator out. So you press your calculator. Let me show you. So we press this. This is a fraction, 39,600 multiplied by 7, then divided by 22 times 6. So I'm having 2,100. That's my r square. R square is 20. Let me clean this. Already I'm through with this. So let me just clean this outside. So I'm having my r squared to be 2100. That's what I get. So that was my answer. So now to get my r itself, this r squared, but I'm looking for r itself. So you take square root of both sides. Take square root of both sides. So r squared equal to square root of 2100. So now, so I have square root of 2100. It gives me what in soft form, but I will have to express it in decimal form because the question says 4 significant figure. So this one is number 1. This r will be equal to 45.825. Now to 4 significant figure, you can even extend it to 748 to 57. So to 4 significant figure, you are going to be what? Having 1, 2, this one is significant, this one is significant, 1, 2, 3, 4. So this one is going to be approximately 45.83 centimeter to 3 SF. 3 significant figures. So that's that about that. So having pressed the calculator and gotten this, we are able to come to conclusion of what? Of 45.8 centimeter for the radius of bigger what? Of bigger cone. So that's it about that. I just quickly drop this one so that I can actually run through this. This is also a cheap question. So I will do that one now by cleaning off all the balls so that it will not be mixed up